Okay, now we in week 10 already. Another 2 more weeks, then we have your test 2. Okay, again, your test 2 will be CL3, CL4. Learning outcome number 3, learning outcome number 4. So one of it is this diagram. Okay, so let's look at this example number 6. Okay, so when you look at the diagram, you should already know what is y-axis, which is your temperature, and then the x-axis is how many components you have. In this one, you have a binary system where you have 2 components, which is PT and AG. Right? As you move forward, is AG, or under the graph, you will see how many percent of something. In this case, is silver. So silver is AG, right? So it's 100%. And then on the graph itself, because we are going to ask you about phase, right? So you have 3 types of phase: liquid, solid, and gas. And also in metal, is rarely you see gas, right? What is complicated for metal is that you have inside solid, you have 2 types of solid, right? Or even 3 types. You have alpha, gamma, delta, and so on. So typically or normally, when you drop temperature from a very high side of your y-axis, or in this case, if you drop your temperature from 2000 degrees C and then you drop down, you will start with liquid. You start with liquid, and then you'll be seeing it start to cool down. When it start to cool down, it start to have a chicken pox, very small particles. Then it will grow, become crystal. Then it will grow until solid. So in this case, like on the blank area here is a liquid. Okay. Then on the left hand side, you have an alpha solid. Then right hand side, you have beta solid here. Right. Then at the lowest bottom, you have a combination of alpha and beta solid. So alpha, beta, they represent different crystal structure. You learn about BCC, FCC, HCP. So it might be any kind of the crystal structure. Okay, so here, previously also learned how to draw the timeline, how to draw the level rules, how to find how many percentage of liquid, solid. Same with this one. Same with this one. So again, I'll show you how easy is it to score marks in the previous example already. So today we go have a little bit of a revision on how you do question on the phase diagram. So here you have a platinum and silver equivalent phrases. So here, of course, in the test, you won't see all this bubble. We'll remove it and ask you to draw. Okay, so you should able to imagine like what is inside here, what is inside this dot here. Okay, so at a point of 42% Ag at 40 degrees C, so what are their phase? Okay, for 400 or 1400, 42% up for here is a liquid plus solid. What is the alpha? Liquid alpha. So here, so you should able to draw what is inside the, what is the phase that you see inside here, the bubble, right? So the question will ask you to illustrate, right? What do you see and what is the phrase that you can that appear in that particular point? Okay, you need to illustrate with the figure. This is the figure that we are looking for. Okay, so here you should draw a bubble and then you draw alpha solid. Then you label alpha. Okay, so here you draw a line. Again, on the phase diagram, it's important you draw a line there. Draw a line. So why we need to draw a timeline? Because we want to calculate how many percent of liquid, how many percent of alpha. You want to find how many percent of liquid, how many percent of alpha. So the step is quite consistent, or there's a SOP to do it. So first you write what is the question asks you, like in this case, 42.4% Ag at 40 degrees C, 1,400. You go to the graph, you draw, and then you drop down the two sides. Then you read from the graph. In this case, on the far left, you get 7%. On the far right, you get 55%. Right. Now, you have two phrases, alpha and liquid. Okay, phrase present, you write phrase present. What you have, alpha, liquid. Then you need to calculate composition of the phrases. So again, you calculate composition of phrases by using level rules. So this is the total length. The point from 7 to this dot here, you calculate percentage of liquid or solid. This line, this compared to total length. Is what? Solid or liquid? You understand what I'm asking, right? You understand what I'm asking, right? You know, like level rules, right? LOS. So if you calculate this to this compared to the total line, what do you calculate? You calculate what? Liquid or solid? Liquid, huh? You calculate, the answer is liquid, huh? If you calculate this one compared to total length, you're actually solid alpha. Huh? Answer correct is solid, but you must emphasize what solid you have. In this case, you have alpha, beta, solid. Huh? If your answer only put solid, you won't get the full answer. Yes, because you have two kind of solid. So if you want me to guess, I'll give you the wrong answer. I'll guess the wrong answer for you. Huh? So you already seen how I mark your test one already. So if you don't have any reason, you cannot give any reason, then you, even though you give me the correct answer, you won't get marks for that. Huh? Okay. So here, 5 composition, you have 7% and 55% of liquid, right? Composition, this is composition of phrases and amount of phrases. They are two different things. Composition and amount of phrases is different. Composition is 70% here. Okay. Composition of phrases, this one is you read from the red line on the left. Yeah. Don't confuse composition and amount. Then this one you read from the right hand side, 55% of Ag. Liquid, alpha liquid. This is alpha solid. Amount of phrases like what we learned in the level rules, right? So the far left, the length of far left is liquid. The short one is solid. So that's why you see the calculation. You take 55 minus 42.4 divided by total length is the one that you calculate for solid. Then this one also. Okay, working is important for engineering module. Working of your mathematics start is important, right? So again, how this section 1, this is 4 marks. 4 marks. Line on the graph, 1 marks. Although there are 3 lines, if you don't draw anything, you miss 1 mark. Then each step will give you 1 marks. Of course, drawing another one. If the question asks you to draw, then you draw. Okay. So because this one already asks you to do the steps here, you already mentioned what phrases happen here. Okay. All right. Now, if you understand what is A, then you should be able to do B. So B, at a point of 42.4% Ag at 1186 plus delta T. So this is what? This is eutectic line, right? Eutectic line. So plus means just above the 1186 degree. So just above is not on this line, just above. So at that point, again, you draw the line. You draw the line and then drop down the two sides. Okay, drop down the two side. One is 10.5 or 10. Drop down, this one about 65 or 60 something, 66, right? Then you do the level rules. Okay, so you write what phrase present. In this case, plus 116 plus T, what do you have? Liquid and alpha. Yeah, it's not alpha beta. It's because the question asks you plus means it's above the line. Okay, then the rest is the same. Composition, you read from the left and right. Right, you read from the left line and right line. Okay, liquid this side, solid this side. Yeah, some students they confuse when they write, when in the answer they cannot transfer the answer. Okay, like for example, the one answer you see on the screen here. Okay, liquid is on the left hand side, because this side is liquid. Right. Then composition, then after composition, then you amounts of phrases. How many percent of alpha? How many percent of liquid? Same. This is a level rules. So total length is here. So alpha to this, alpha is solid, S, O. So this length is liquid. This length compared to total length is liquid. This length, this O to L is solid. It's the same. The numbers you don't need to remember lah, and as long as you understand the steps or how you calculate the numbers. Unit is important. Don't miss out the unit. Okay. Next one is temperature just below this line, still 42.4%, but the temperature is just below 1186. What do you have? Alpha beta solid. Okay. So alpha beta solid. So in this case, the temperature just below of 186. Okay, it touched this line. So of course, it will be a bit confusing when it reach this very short line here. Right. So again, in the test, you'll see a very big graph. In this one, you only see beta because beta is this section joined to here. Okay. So when you enter into this space, only you will see liquid. On the line, you will see solid. On the line, you see solid, just a little bit lower than that one. So in this answer C here, you only see beta. Because this section is beta. So this line is beta. Just a little bit. Of course, on the graph, this is a small graph. If you enlarge it, you will see it's touching actually on the beta line. No alpha. Okay. Okay, so this one you straight away you read it's 42.4% beta. Yeah. So this one highlight and this one normally is the careless mistake. When you see a very complicated line, this one this one for PBAG graph. Amount 100% solid. Okay, again, unit is percentage, WT percent. Because you only have beta. Okay, then another one, 60% of AG. 1105. 1150. Yeah. So here you at this region alpha liquid and beta, right? So again you draw line, the time line, and then you drop down. Left hand side, right hand side, LS. Then this one to this one is what? Calculate percentage of liquid or solid? Liquid. You You calculate the opposite one. Okay. Then the rest is okay already lah. So once you follow the structure here, you write what you see, you write phrase present, what is inside that region, on the dot itself, what do you have? Then you write composition. Composition, you just direct read what you have from the graph here. Okay, composition. Then amount only you do calculation. Don't confuse with composition and amount. Okay, so this one you know already. Okay, next we learn about, just recall, this one you've seen this one already. Previously, you know about something called peri-eutectic. Peri means liquid and salt and alpha. It cool down, it become beta. Another one, this one, paritetic, eutectic, you know lah. Eutectic liquid become alpha and beta. So this one you need to memorize a little bit. What is paritetic, what is eutectic? Because on the graph, sometimes you will see either this one or this one. Sometimes both on the same graph. The process, right? So like, for example, on the line, you will see when you drop temperature, you will see liquid alpha, L plus alpha, you become beta. Then that one is paritetic. When you drop temperature, liquid, you become alpha, beta, then it's eutectic. Okay. This one is monothetic. Monothetic is liquid. You cool down, you get liquid L2 and alpha. So this one happen in a copper lead system. Copper lead system. Example this one. Okay. So this is monothetic. Monothetic, again, the equation is liquid 1 become liquid number 2 plus alpha. So it happened at 955 degrees C at 36% PB. So where's 36 is here. Okay. So this dot here, this line is called monothetic. So you see liquid, when you drop temperature from this line, liquid it changed into alpha plus L2. Liquid number 1 become alpha plus liquid number 2. So as a result, terminal solid solution, almost pure lead and pure copper are formed at the room temperature at here. Okay. So you see something like this in the microstructure. Okay, so we add lead into the metals, into the alloy, so that it's able more easier to do machining. The reason we add this component inside our alloy is to make it more easier to machine. It reduces ductility. Okay, three different, this is an important diagram that help you to identify whether it's eutectic, eutectoid, peritectoid, monothetic. This is this one is last class. When you go inside more and more, again, this is a summary of what you should know. Okay, so for your test 2 and final exam, remember this one. Yes. Okay, so even the diagram already give it to you. What will you have, right? If you see, this one is your cheat code lah, like cheat code like what I teach you for the periodic table, the SPDS, same. It's a cheat code. It's a cheat sheet lah. So it's like when you see graph with alpha, beta, left side, right side, with a V in the center, usually is a eutectic process. Okay, when you see beta, gamma with the alpha at the center, then it's a eutectoid. Then alpha liquid, beta below is a paritectic. Then alpha, beta, but gamma below is a paritectoid. Alpha liquid 1, liquid 2, then it's a monothetic. If you see 2 liquid, it's a monothetic. Okay. Then equation is important for phase diagram. The question will ask you to write the equation for the process. Okay. Okay. So this one you read lah. These are the side note. What is the differences between eutectic, eutectoid, and so on. Okay, these are the industrial process. This one you read from the slide lah. Okay. This is a steel making process. How they make steels. They pour in, they pour out inside the mold, and so on. Okay, so as an engineer, we only need to know why we add something. For example, why our chemistry colleagues, they add carbon or coke, they call it coke, inside the process. Because by chemistry process, our ferric oxide plus CO, it will come out a pure metals and give you the CO2. So in the furnace, that's why they pay you quite high salary because of this one. You suck too many CO2, you see, it's like you are suicide lah. No, it's not cancer. You will die. Because this one, although they give you the tag, the sensor, but when you do working, you know lah, when you work, how often you will see your sensor, right? Unless your colleague see lah. You only can see your colleague sensor. Right? No, they just pull in carbon. Just put in carbon. Huh? No, this is just tell you that there is a risk hazard. There's a hazard in the factory that make steel. Okay. Because for those operator, they work there. Normally, their qualification like only certificate. They don't learn all this process. They just want to get money or say, oh, you pay me more money, I work lah. Okay. Then they don't know why they feel so sleepy every time at the work because this. Of course, your brain lack of oxygen. Okay. So that's why they wear all these masks and all these things. So another one, yeah. So they add in carbon. The main purpose in the steel industry, they add carbon is to make the pure, to get back the pure iron. And carbon monoxide also very dangerous. CO. More dangerous than the CO2. This one, it will absorb in your bloodstream very fast. Okay, these are the industrial floor, iron cast, and sorting. Okay. Now, what is important for this phase diagram is iron carbon system. Now, previously we looked at other pure metals, copper, gold, silver. Now, introduce you iron carbonate phase system. For example, again, when you read phase diagram, please read the y-axis and x-axis first. Y-axis is the temperature. It will tell you the melting temperature, and then x-axis it tell you how many component you have. In this case, you have 2 components, carbon and ferrum. So here you look at the caption. This one is focused on the carbon. Means if you move towards the right, you have more and more carbon. And on the iron carbonate phase diagram, it won't give you until 100% because in the industry, you don't need to reach until 100%. Yeah. Fe3C is a ferrite 3 carbon. Okay. So or it's a carbon percentage lah. So Fe3C. So here again, important that you know you have 3 phases: liquid, solid, and gas. For metal, is impossible you will see gas, right? Unless you go to other planet lah. Like for example, sun surface, then you'll see metals, gas, and so on, right? So here you see liquid, then you drop down, then you get solid here, and there's a community here, very small, right? But also important, you'll see delta, gamma plus delta, liquid a little bit here, liquid plus gamma. All these are solid already. Different species. So gamma, delta, alpha. Okay. Which one? Fe carbon. This is carbon percentage. Carbon percentage. Okay. So iron carbonate is Fe3C. It's formed. It's not a true equilibrium phase. So sometimes chemists they call Fe3C as a cementite. Cementite. Okay. And Fe3C cementite is very stable. So it's because their form is very stable, so we treat as an equilibrium. So again, this is a very popular graph for your assessment. So again, if you compare left and right, actually they are the same, only they stretch it longer, bigger, and more clearer. For example, this one compact, right? So they stretch the graph. So they reach until 6%. Here here also 6, but very short. So they stretch it. So you see some space here. Here you very hard to see. Okay. But anyway, the phrase, how you read it is still the same. You can still do the phrase analysis, component analysis, and so on. Same. Yeah. Which one? Yeah. Yeah. Yeah.
Yeah.
Reach
until 400.
Alpha plus this one. Where?
The lowest point is
Yeah.
the red line, yeah, lowest point 400.
400.
The right graph, the lowest point only 590.
What's the unit? Celsius and Fahrenheit. Left and right. This side is Fahrenheit. Yeah lah, it's stretch ma.
Very big difference of degrees of.
Yeah lah, this is usable lah. It depends on. This one is a bit older. This one a bit newer. But if you stretch it, you will see this line will go down to about there lah. But again, important is you know how to identify what you have when you reach that point. What you have. So again, back to the table just now. The 5 phrases important. It's important you memorize. Okay. So these are the solid phrases you have: alpha, gamma, Fe3C, delta, and so on. So each one have their own name: ferrite, austenite, cementite, ferrite. So when you see this one, of course, the name will be on the graph itself lah. Only this one, maybe some of it you don't have, like delta is what? Ferrite and all this. Okay, so again, link back to your chapter 2. Alpha is BCC, so BCC is something like that. At least you should know what is the form of that one. Alpha ferrite is BCC. It's here. So alpha appeared at this region and not above. Okay. So this one is just here lah. So reach a maximum solubility. This is carbon lah. So if you drop down, your carbon is very, very low. So means even you mix a lots of carbon, it can only absorb that much at this temperature at about 700 something. Even you add a loss of carbon, it only can absorb 0.022%. Solubility of alpha ferrite decreased to 0.05 at 0 degrees C. This one very, very low. It is PCC. So technically, carbon is very difficult to fit inside this structure. So in chapter 2, we already given you the radius of the carbon. And you already know how to calculate the diagonal distance A and the R for BCC. So if you draw this diagram, you cut this diagram out, you should be able to find the space here. If you draw the A and R diagram, so this is, if you draw this one or like this one, so you know your R, right? The R, so this one is R, but this is the space, right? You know your RBCC crystal structure A. So there is a space here. Then this space, your carbon cannot fit inside there. Because carbon, if carbon size too big, cannot fit inside. So that's why this one, it only give you very, very low solubility because of the crystal structure. Then it increase temperature, it will expand. So more and more carbon can fit in, but still cannot more than something. It depends on the temperature. It depends on the temperature, but it changed shape already. Okay. Next one is gamma or externite. Gamma is over here. Right. So we got this one, this section. Okay. So it's a FCC. BCC here, BCC changed to FCC. BCC changed to FCC. So you see the carbon can fit inside the, not ngam lah, but more space for it to fit carbon. That's why you see from 0.022 to 2.1%. Okay. So this is right. Okay. But again, not all of them, but there's a space for it to park. Okay. Then cementite. Cementite is a hard and brittle carbon. Basically, it's a carbon. Ferrite delta. Delta is over here. Okay. Still here. Okay. Delta is BCC again. So it changed from BCC to FCC, then back to BCC. Again, you see BCC can only absorb a very, very low carbon. That's why it stay on the left. Paritatic, again, this one you refer to the table just now. Paritatic is liquid plus this phase solid, you get another solid. So paritatic, you get this reaction. Again, solid 1 becomes solid 2. So this one, 145 here. This line is parenthetic. Parenthetic gamma become another gamma. Okay, another gamma here. Okay. Then eutectic 1148 about here. Eutectic is liquid become gamma plus the Fe3C. Yeah, about this region, this region. Eutectoid is at this region. Again, what is eutectoid? I'll just refer to the table just now. Just to it will not be given. But when you see phase diagram, you remember that table. You write on your answer sheet, you still will get some marks there. Okay. And so on. The rest you read. So you have hypo and hyper also. You have hyper and hyper also. Okay, so the question would normally go like this lah. Hypo is back, hyper is front. Okay, so you see 0.77% carbon, eutectoid plain carbon is slowly cool from 700 degrees C, 750 degrees C to a temperature slightly above 727. Assume austatite is completely transformed to alpha ferrite to cementite. Okay, so calculate the weight percentage. This one link back to chapter 3. This one also link back to chapter 3. So first, you should find where is the line first on the diagram. So 0.77% cool from 750. 750. Okay. So about here lah. So 763, slightly below this one. So it's at this area. Okay. So you draw a line. It's about here. You draw a tie line below 727 from alpha ferrite phase boundaries to Fe3 phase boundaries. You draw a line. Okay. Here lah, it point you to this one already. Okay. Then you calculate how many percent of for eutectoid form. So here you calculate 0.677 because it's a very long line here. So you take from maximum 66.7 minus 0.77 here. Okay. Because the n here is 0.022. So you have this and this. Okay, LOS, L, something lah. Here you don't have L. L is above. Here you don't have L. Here is here. But again, it's the concept still same. It's the opposite. You are finding percentage of ferrite. Alpha. So you take this length. You need to remember. You need to remember. So this slides, this this one. Okay, remember. Okay. But sometimes we will help you in the question you write alpha. Okay. So same with the B. The percentage of eutectoid cementite is another side lah. Okay. So it's either this side or another side lah. Okay. But for this carbon or iron carbonate, there's no more LOS, but the concept still same. Right. Again, alpha is ferrite. Another side is this one Fe3C, cementite. This one, Okay. So B, he asks you to calculate hypo eutectoid plant carbon steels, 0.4%. Very, very low here, 0.4%. From 940, 940 is about here, right here. Okay, so you go to that lah. So you draw the line. Of course, in the exam, you see very big graph. Okay, so here, 0.4% you draw. Then, because the question asks you about the the hypoeutectoid, use the same lah. Use the same lah. So here you have a three phrases here, here three dot here, here, and here. So here, if you drop down, you get 0.4. Then another one is the 0.22. Which one? Stop at here. It asks you the hypo is about at the back. Okay. The rest is same lah. So it asks you about austentine. It asks you about pro-eutectoid. So get familiar with pro-austentine and all this. Okay, the rest is same. You read lah. Okay. So again, this slide going back. Go and find percentage of cementite, how to find eutectoid, and so on. Okay. Okay. So again, go home, go and read the slides because all these are new terms for you. Maybe you're still not familiar with what is eutectoid, cementite, and all this. So go home, go and read all these, the previous slides. Go familiar with what is all this. Okay. All right. Okay. So phrase diagram is a very big diagram. It's a very big chapter. So, but again, if you see this graph, you should be able to understand what you have lah. Okay. So you see this one is a gamma, alpha, gamma, and then this line, you have a eutectoid point, alpha, and cementite or carbon. That one you refer to the table just now, the equation. Okay. So here, at this point, A here is a full gamma, and then you drop down temperature again. The gamma will change to alpha and Fe3C, or we call it perlite. Okay. When it drop into this region. This region is called perlite. What? Here gamma. Here gamma, you drop from this point. Here is full gamma. So at which point is full gamma. Then you will be on. If you move to the left, you will see alpha gamma. If you move to the right, you will see gamma and carbon. And there's a small gap here. There's a small gap here. So the eutectoid is this line. Below 727, you will get eutectoid. This black line below is alpha plus Fe3C. Okay. So of course, in the test, you'll see this black line is a blue color line, and with the temperature. Okay. So the rest you read. Okay, the rest you read. Okay, so this is another example. So perlite perlite is alpha plus carbon, alpha plus Fe3 carbon. It looks something like that. It's like a pearl, like that. So this is a eutectoid, hyper-eutectoid, and so on. So, for example, the same phase diagram, we shift it a little bit to the left. Then we drop temperature at 0.4% carbon from maybe 1000 degrees C. So we drop here, we will see gamma or a bit gamma. Then we drop until we reach this line. It will change gamma into gamma alpha. So there's a little bit of alpha growing in the line here. Okay, so again, in material, don't go and grow chickenpox inside here. It's grow on the space here. Means the two line, there's a gap there for it to grow. It will grow on the gap. So don't go and draw chickenpox inside there. Because inside you already have all the metal already. How it suddenly go inside cannot run. So it will grow at the boundaries there. Line. You see it draw on the line here. So the line will grow a little bit. So this one is alpha. So it drop down, then you see the chickenpox at the line there. Then it grow bigger and bigger. Then when you reach before 720, you see the chickenpox grow at the grain line there. So you will like try to squeeze out the gamma out. Then you drop below 727, you will see perlite already. Means you switch to all the gamma will flip to alpha. You will flip to alpha plus the carbon, Fe3C. Okay, you'll see all these are become alpha. So this one alpha, then this one will be squeezed out already. Become fill with the carbon. You have a little bit of carbon and all this. Okay. Yeah.
Okay.
So the rest you read lah. Sorry. Okay, so this one is a hypoeutectoid equation. Hexadite, ferrite, but cementite. Okay, this one you read lah. Okay, then this one another illustration, like you drop. This one is the iron carbon diagram. So again, you drop from maybe 1000 temperature, then you drop. Then you see whether you understand or not. This one is gamma, so you have all the gamma. Then you drop below the same composition. When you pass this line, you will change shape to this region. This one is what? Need to check the big diagram. So this one is you have alpha, gamma, and carbon. You see, it grow on the line. Don't draw chickenpox inside the solid things on the grain. Then the grain will grow. You squeeze out the things. You squeeze out the gamma, then it drop, it become perlite already. You will see all the blue color is the carbon, Fe3 carbon, and this one become eutectoid alpha. Okay, so here you have a eutectoid and pro-eutectoid. Pro means before this it grow already. Pro means at this stage. Pro means this one. You see this one. See here. Then the new form one, they call it after this line, they call it eutectoid. It's just a name different name first generation, second generation okay. But you name this whole thing as a perlite, also give you correct one. Yeah. Okay, so this is another one, same things, it's just different illustration. So if you cannot remember what is pro-eutectic, you cannot remember pro-eutectoid and eutectoid, you combine two, you write perlite, also give you correct one. You combine these two, you combine become perlite like this diagram, also correct.
Okay.
So again, important part, you don't draw something the chickenpox in the middle here it's grow in the line there. Yeah. The rest you read, this is hyper-eutectoid. How hyper-eutectoid can form. Yeah. It's just a different name lah. Okay. Okay, so this one is hyper. Again, you see the line when it become right hand side one is become hyper. Just now is hypo. The previous one on the left, on the left is hypo. This one on the left is hypo, but still the same. You just follow the line and then you try to draw what it will still form polite one. Okay, so only you need to identify where is hypo, where is hyper. So this is hyper. Hyper is on the left and right hand side. Okay. Again, it still form polite, but different things lah. For example, here you don't see alpha. Hyper one you don't see alpha, but hypo you will see alpha. You'll go through alpha. Hyper least set ma, so you don't see any alpha here unless you reach this after this 727 degrees C, then only you see alpha. Yeah, so don't confuse between hyper and hypo. Okay. Okay, so what is the careless mistakes or how we test you whether you understand hyper and hypo? So either we test you on the left hand side or right hand side, and we want to see your drawing here. Your drawing, this one. The composition, the component. Okay.
This one I just label feel like also can.
This one you can. But here you want to see gamma and Fe3C, but here you will see alpha. Like this one. You will see this one hyper one, hypo. You see, this one you need to alpha, you need to label alpha. You need, because here got alpha ma. Okay. Don't come and see me. Hey, Dr. Ang, I draw the right correct why I don't have marks? Because one is hyper, one is hypo. Okay, that is important. This is more complicated one. This is a summary. It's like a map. It's a complete map of what is a carbon equilibrium diagram. So, of course, you don't need to memorize this one. It's just this one is when you do research in material, then you open this one. Right? So, for example, you want to study this material and this material. So, you set your experiment at this temperature, this composition. You don't start at here, but you start at somewhere here. It's like a map. Okay. Yeah, again, this important. These four members here. The name. Okay. CM is cementite, the Fe3C. Okay, so another one is this. This is also another map that is important, help you to understand the FCC, BCC form. So this is Axonite, FCC, ferrite, BCC, cementite, this form, but of course I won't ask you to draw this one. But this one highly will come up. We'll ask you what is the crystal structure of acetine or ferrite. Draw lah. Give you a chance to draw lah. Again, don't miss out the dot. And again, some of you miss out the dot. Okay, this one another more detailed one. Of course, it depends on the question that will come out. Yeah. Okay. So just have a quick look. Then we have a short break. So this question in the beginning, it asks you about hypoelectroid, left hand side. So hypo is this V-shaped left hand side. No, you see something solid, then nothing, then there's a V shape. This line is eutectoid. This line V and the dash line. This is called eutectoid. This is called eutectoid lah. You see the V, left hand side of the V. Right hand side is hyper. Hypo left hand side. Okay, hypo, you know, is on the left. So it's a slow cool from something to something. Region to room temperature contain 9.1 eutectoid ferrite. Assume no changes in structure. On cooling, just below the eutectoid temperature to what is the carbon content. So let's say you don't know, but you know that it's on the left hand side. So you draw a line, X there. Okay. Normally, the question will give you a blank one. You won't see this line. You won't see X line. So what you do, you go to this line here, you draw anywhere on the left hand side, you draw, then you label X. Okay. So you know that total ferrite is pro plus eutectoid ferrite. So you want to find eutectoid ma. So you just change this pull, you just pull pro to the left hand side. So Revel rules. In this case, you are given 9.1%. So you use level rules is 0.091. You move two space in front and get this one. Okay. Then total ferrite is Ref minus X divided by total length. Okay. So here to here and here, you want to find how many alpha you have, ma? Total ferrite alpha minus pro eutectoid. Another side lah. So 0.77 minus X here. Okay. 77 minus X here is another side. Pro eutectoid. Omok lah. Then you find your X lah. You rearrange the equation. There's only one unknown. Then from there you find your X. Okay. Ada lagi. Okay lah. We have a short break. We continue 11:10.